2A, 2B, 6. Oh, my Lord, it's so easy. 7B. Think about the terminal point for pi over 3, which is 1/2 root 3 over 2. So you've got your cosine value, you've got your sine value. You multiply it all together. Boom, done. 6 times the cosine value times the sine value. Wasn't that it? 6 cosine sine?
What number are we on?
Let me do 2A. All right. Oh. Y'all are, you said 3B, Steph? Okay. So here we go. Let's look at this. 2A. Now, folks, now keep in mind, you may not see things the way I see them, but you should at least be able to think your way through this problem. Tangent, I don't think it's, yeah, x plus cotangent x squared minus 2 equals tangent squared x. Why do you wait until now rather than ask while you're doing the problem? Slackers. Here we go. I told you, yes, you're welcome. I told you yesterday that you needed to write that quantity twice, okay? Now, when you write that quantity twice, I'm going to FOIL this thing out, and I get tangent squared x. This is weird, but I'm going to write it. Tangent x cotangent x. And I'm going to write it the same way. Cotangent times tangent is tangent cotangent. And then cotangent times cotangent is cotangent squared minus 2. And I've got all that right side I haven't done a thing with. Now, folks, that's a perfect square trinomial. What is 1TC plus 1TC? 2TC. That means it's going to be tangent squared plus 2 tangent cotangent plus cotangent squared x minus 2 equals the right side, which I'm not going to mess with. Now, when I've got tangent and cotangent together, side by side, being multiplied to one another, that kind of should make your ears kind of perk up a little bit, because something's going on here. Aren't they reciprocals of each other? They'll equal 1. I'm going to write it like this because I need to see the work. Okay? Plus cotangent squared minus 2 equals the right side. And look what's going to happen. They will equal 1. I'm going to mark that out with 2. And it leaves what in the middle? 2 times 1 is 2. And now what? The 2's cancel. The 2's cancel, and I'm left with tangent squared x plus cotangent squared x equals tangent squared x plus cotangent squared x. Okay? Does that help? All right, I'm going to run through. If you miss it, if you miss any piece of it, it's your responsibility to go back and watch that video. 2B. All right, 2B. Another verifying. Folks, I think you've got 2 verifying problems on the test. Let me say this about the test real quickly. I can't give you a whole lot of these problems because they take a long time. So I think you have 7 problems, which is going to be exactly like what you've seen on this worksheet. Different numbers, different letters, different that sort of thing. Same concepts. Folks, what's that mean, though? If I give you 7 or 8 problems, what's that mean? Oh, Lord, they're going to count a bunch, okay? You got to study. You have to study for this test. You have to finish it in one block. You got to come in here and roll, and the first one you need to roll on is that problem like 6 sine cosine. You know, you got to roll on that one fast because that one, so it really does, it's just easy, Okay? I will do that, I promise. But when you see it, you're going to be like, oh. Yeah, that's what you're going to be like. Okay? 2b, here we go. So, all right, this problem, I got to work both sides of this. Okay? Common denominator. Folks, what's my common denominator going to be? And I'm not going to show every step. On the left side, what's my common denominator going to be? All right, if I multiply those two denominators together and I FOIL it out, what's it going to end up being? It's going to be a difference of squares. Cosecant squared x minus 1 plus cosecant squared x minus 1. What did I multiply to the bottom of this one? Cosecant minus 1 times 1 is cosecant x minus 1. What did I multiply to the second fraction? Cosecant x plus 1 times 1 is cosecant x plus 1. I just skipped 2 steps, and it took me 2 6-weeks to do it. Smush it together because we have like denominators. Combine like terms. My 1's cancel out. What's cosecant plus cosecant? 2 cosecant x. Kind of the same thing we did just a few minutes ago. Okay? And I'm going to go ahead and write 2 tangent x over cosine x because I'm going to move my screen up. Okay? Now, what now? Card. Look at your card. What is cosecant squared minus 1? One more time. It's cotangent. 2 cosecant x over cotangent squared x, isn't it? Now, what in the world possesses me to throw that cotangent squared in there? What do you think? Why do you think I would keep that in there? Any thoughts? I've got a tangent on the other side, okay? Somehow that makes me think that I'm going to make something happen there, okay? At this point, first block this morning when I did this problem, I got right here and I went, oh, I could have done what here? What could I could have cross multiplied. Now, I didn't do that when I solved the problem. Did anybody cross multiply on this? Was it easy or was it difficult? It was easy. I just didn't go that way. You could have, okay? Okay. Do you know what I'm doing? Okay. Cotangent squared. I am going to change that to, how can I change that? Cosine squared over sine squared. I'm going to leave that right side out there. I'm not going to mess with it. All right. That's going to give me 2 over sine x times sine squared x over cosine squared x. Now what? I lose a sign. My signs cancel. One of those cancel. And I get 2 sine x over cosine squared x, which is going to hopefully somehow end up being 2 tangent x over cosine x. Huh. Can I make you believe something here? Okay, you're right. I'm just working on the right side for whatever reason. Just watch what's going to happen. Do you guys agree that 2 tangent x times 1 over cosine x is 2 tangent over cosine? Do you guys buy that? Is this true? Does this product equal that right there? Yeah, it does. Okay, we're going to think about multiplying fractions in a different way. Tangent can be what, Anna? Sine over cosine. Do you see where I'm going with this? What do you think? Is that doable? Yeah. Does it make sense? Jessica, was it easier to cross multiply? No, this is a proof. You can't just look at it. Show it. I ain't thinking about nothing. Wrong. I get yes. If you think about it, yes. But this ain't about, it's not going to say, think about it. It's going to say, verify. So it means you got to show every step. Okay? Questions on it? Wouldn't that be funny? I do understand what you're saying. And you're right. You are correct. I got you. Okay? Yeah. All right, here we go. Three B. 3B. 3B. Sine of 7 pi over 12. Folks, you're going to have to use your sum or difference formulas when you've got these weird angles that we don't know the name of. Okay? So here we go. 7 pi over 12 is 3 pi over 12 plus 4 pi over 12, isn't it? But I don't know anything about 3 over 12 or 4 pi over 12. But when I reduce, I do know something about pi over 4 and pi over 3. Do you guys agree with that? Good. What's the terminal point for pi over 4? Root 2 over 2, root 2 over 2. What's the terminal point for pi over 3? 1/2 root 3 over 2, correct? Now, I got everything I need. I got my cosine value, I got my sine value. Am I going to use the sum or difference formula? I'm going to use the sum formula, okay? And it is sine of pi over 4 cosine of pi over 3 plus, wait a minute, 3 pi, shoot. Yeah, it's all good. Hey, what do you have to be careful of? Something else you have to be careful of tomorrow. Because you are killing me. Something else you need to be careful of tomorrow. You better double check and triple check and quadruple check your formulas. Because if you use the wrong formula and you work it all the way out and you get the correct answer for that formula, it's still going to be wrong. And that would stink. Yeah, bad. That would be horrible. Please check your formulas. Some of you came back over the last couple days and you said, why don't we figure out what I've done? And then I look at your formula, and that's where we found a mistake. Please don't make that mistake. Please. All right, sine. Well, what's the sine of pi over 4? Root 2 over 2. What's the cosine of pi over 3? 1/2. This is just multiplying and adding fractions. Cosine of pi over 2 is root 2 over 2. Sine of pi over 3 is root 3 over 2. Folks, multiply across each set of fractions. Root 2 over 4 plus, what is the root 2 times root 3? I have it up there. It's already root 6, right? It's just multiplying, folks. And can I literally combine root 2 with root 6? No, they're not like terms. Therefore, boom. That's it. Okay? I think by the time all this is said and done, I've worked every problem on this review. And if you want to go through here and watch every video, they're all on there. Okay? Where are we now? 6. Tucker, what's the terminal point for pi over 3? Right? 6 says 6 that's what it has, right? Okay. Let me ask you something. All you do is multiply. Okay? And we haven't done any, we kind of done something like it, but really not just straight up like that. But if you know these angles, and you should, that should be a piece of cake. You tell me. Say what? Yes, sir. Yes, sir. Okay. Let me ask you something. Can you have the special angles on your card? Psst. Can you have the special angles written on your card? Pi over 6, pi over 4, pi over 3, pi over 2. No. Don't make me check your cards tomorrow, because that would be awful. If I took your card and I saw it and then I went, oh, that would be so mean. That would be bad. That would be me being a real, and I can be a real when I need to be. Okay? They better not be on there. So if they are, you better get rid of them so I can't see them. What next? Wasn't there a 5 in there somewhere? No. 7B. 7B. Here we go. Yes. 7A was 7 root 2 over 7. Excuse me. Yes. And this one was negative 4 root 17 over 17. Yep. All right, so here's 7B. Secant of x, stop talking. 3 pi over 2 less than x less than 2 pi. And we got to find cosine of the half angle. Folks, am I going to tell you to use the double angle formulas? No. What will it say? Instead of me writing out, use the double angle formulas to solve this problem, what will it say? It'll say find cosine or sine or tangent of 2x. I will not have. Use the half angle identities to solve for. What's it going to say? It's going to say that right there. Okay? Can't you? Y'all are going to hear me saying that tomorrow in your test, and then you're going to giggle out loud, and I'm probably going to get mad because I'm going to think you're cheating. Just remind me. You went there. Okay, here we go. What's that mean, secant x? It's just cosine flipped. I don't care about that. I care about this, don't I? How much prep work do we have? A lot for half angles. Do we have all that prep work for double angles? No, we got a little bit, but not a lot. For double angles, trust your signs. For this, we got to go through and we have to do 2 sets of prep work. Here we go. So here's my x. Cosine. Some horse called a horse. What the world? What's that other angle? Other side, rather. It's 8. If you don't recognize that this is a triple, then do the Pythagorean theorem and solve to get 8. Yeah. Okay? We got 8. Now, what do we have to find? What quadrant is this in? If it's in 3 pi over 2 less than x less than 2 pi, what quadrant is this triangle for angle x in? This is... It's always good to be confident. Even if you're wrong, be confident. Let's go with, what do we have to have? Cosine of the half angle. Cosine of the half angle is plus or minus 1 plus cosine x over 2. Folks, what's the only value I have to have for this triangle? I only have to have cosine. So my cosine value is, it's what I had. I'm not there yet. I'm getting there. Because I have to find cosine of that, which was given to me. Now, what's my other step that I'm skipping, that y'all think I'm skipping? The X. We got to find the half angle.
Why do you have to do that?
Because we have that. Because why do I have to do that? Somebody tell me why. Say it again. Because we have to determine where that half angle is. That's our regular angle X. That's the one we use and we kick to the curb. Yes, sir. That's exactly right. All right, so how do I get that half angle? Divide everything by 2. And if this right here, 3/2 divided by 2, is going to tax your brain, put it in your calculator and math bracket. You get 3 pi over 4 less than the half angle less than pi. Where is that angle, that half angle? Quadrant. Who is saying? Negative, positive, negative. Cosine, sine, and positive. This I use for my what? For my answer. That's for my answer. The sine's for my answer. So, if I'm finding the cosine of the half angle, am I going to have plus or minus? Over here? I only need the negative. And then here we go. I'm going old school. Cosine of that x is 15 over 7 divided by 2. And that's 17 over 17 plus 15. Stop talking. I'm glad you're finished. And then what's 17 plus 15? 32. You're right. You made him cry. Thanks. I know. Wipe those tears away. It's okay. Here we go. And then I'm going to cross cancel, and I get 16 over 17. Folks, isn't that 4 over root 17? Now, what's wrong with that? Rationalize it. 4 root 17 over 17, and it is negative. Questions? Other questions? My third block, I know I've worked every single problem. You just got to find the right video. Okay? Any other questions? Any other questions?